So in this part of the question we're asked to find the upper quartile Q3. And the upper quartile, remember, is where the probability of being less than it is 3/4 and the probability of being more than the upper quartile is 1/4. So the upper quartile Q3 is going to lie somewhere to the right of the 30. So let's just say that this is Q3. And we'll put on the fact that this area to the left of Q3 is 0.75. Just put that in there. And it's good to select this area to the left because when we project our value down onto the standardized normal curve here, then we're working immediately with the area to the left of that particular Z value here, which we'll call Z1. So, what we know is that the probability of Z being less than Z1 is going to be 3/4 or 0.75. So this is very useful to us, as you'll see as the question develops. But what about Z1? How can we relate it back to Q3? Well, remember that any Z value, Z1 in this case, is equal to the observed value minus the mean all over the standard deviation. And the observed value in this example is Q3 minus the mean of 30, and it's all divided by the standard deviation, which is going to be 8. The problem is we can't find Q3 because we don't know Z1. So we've got to find Z1, and as I say, this is useful to us because we know that if we were to look in tables, they give us the graph of the standardized graph, which we know is going to look something like this, and they always give us the values of probabilities less than a particular value of Z here to the left, and Z is to the right of 0. So this is looking good. We've got 0.75 here, so we're looking for an area here to be 0.75. So what we've got to do is look in our tables. So if I just draw you an excerpt of those tables again, we're going to have the two columns, Z and the probability that Z is less than Z. And what we're looking for is to get, in this column here, we want this area here to represent that probability to be as close as we can to 0.75. Now in the tables I was looking in, I found 0.7486, and I also found below that 0.7517. And for 0.7486 there was a Z value of 0.67, and below that was 0.68. So I had to make a decision which one of these two was the closest to 0.75. Well, this was 14 units below 0.75 and this one was 17 units above 0.75. So clearly I wanted to select this one here. Okay? So what that was telling me is that from tables, and I'll write this in the exam, from tables I can see that my Z value, Z1 in this case, was equal to 0.67. So all I need to do now was just substitute 0.67 into here. So if we just called this equation 1, say, I could say sub in 1. And if I sub that in 1, we've got 0.67 equals Q3 minus 30 all divided by 8. And so all I need to get Q3 is just to rearrange this, and if I multiply both sides by 8 I get 8 multiplied by 0.67, and then just simply add the 30 afterwards. And if you work that out you end up with 35.36, which I'd round to say 3 significant figures or 1 decimal place, and that would be 35.4 to 3 significant figures. And also a glance over here shows me that it's certainly to the right of 30 and therefore seems a possible answer. Well, indeed, it is the correct answer. Alright? Okay, so I hope that's given you some idea then how to tackle that part of the problem.